I was actually working on a project that was essentially how do we measure intelligence in AI? Because we want to measure essentially how smart AI is compared to humans. And right now, we just kind of have a lot of benchmarks. Like, does it do well on the specific task? What's the accuracy that it achieves on that task? Yeah, people at IBM were like, we need a better test that measures general intelligence so that we can know which models are most likely to lead to general intelligence. And yeah, so part of that is defining what intelligence means so that you can get to testing intelligence. And then part of defining intelligence is like, how well does something understand other concepts? So, yeah, for understanding, it's a tough definition, but the way that I was thinking about it in the past was essentially the complexity. So, like a water bottle is a pretty simple concept. There's not too many features associated with it. It can only do a few functions. Something like flying to Mars is a pretty complex concept. It requires a lot of understanding of rocket propulsion, physics, and yeah, knowing about Earth and space and how gravity works.
Correct. Yeah.
Okay, so that's like simple concepts versus complex concepts. And then how to test if you understand either of those concepts could be done through more specific benchmarks like we currently have, like object detection or being able to predict what's going to happen next in a video frame. So those are different skills that AI can possess. So my thought for how to test if AI understands a concept was essentially to say how many different skills can the AI accurately perform on a concept. So can it detect the water bottle and can it detect flying to Mars? Can it predict that that's going to happen if like there's a scene right before it that's about to happen? And like could it decompose it into all its subcomponents? And there's many skills that could be defined for AI to perform on a concept. So my thinking was that for determining the understanding that AI has in a concept is how many skills can it perform on that concept.
Yeah.
And then intelligence kind of comes in here, where how complex are the concepts that AI has performed the skills on? So if it can understand more complex concepts, then it's probably more intelligent.
One thing I'm thinking is if you want to figure out if an AI is more intelligent than humans or human intelligence, right? Then we also need to figure out how to measure human intelligence.
Yeah.
The idea about having a general intelligence from a machine perspective is that it can do what we can do, right?
Hmm.
And to figure out that general intelligence, artificial general intelligence, is better than ours, how do we measure ours first?
Yeah, that's definitely a big topic as well. It's like IQ tests have been done to try to measure people's, yeah, kind of general intelligence. And kind of what you're describing, like tasks that we can do that AI should be able to do if they're as smart as us, that was kind of like the first, or well, it's called, I think, the Wozniak test. And it's essentially if AI can go make a cup of coffee, like just walk into any room and make a cup of coffee that has a coffee machine, then it's as smart as humans because that takes so much coordination and knowledge of what to do. And then there's also like a Turing test. If you can talk to, if a human talks to AI like through a black screen and can not distinguish if it's AI or human, then we've reached artificial general intelligence. And in those two scenarios, you don't really have like, oh, we're 50% there, we're 75% there. You just kind of have like, we're there or we're not there. Yeah, that's debatable. The Turing test, you could potentially say like, oh, well, they fooled you for 5 minutes, so it's certain length of time. But yeah, the intelligence test, there is someone named Francis Cholet, and his model is for testing intelligence is like pattern recognition, essentially. And I think that's more akin to the intelligent, like the IQ test, where you're given, yeah, in his scenario, it's like you're given shapes and like a before and after for one example, and then you'd see a new shape, and now you see the before, and you have to determine what the after is. And yeah, I think that gets us part of the way. I think it like shows some underlying knowledge or ways of like processing data that is interesting and is useful for pattern recognition. But making the step from being able to detect shapes to being able to detect cancer and like the intricacies of the human body and just visual components and audio components, that feels like not a straightforward transition from just like shapes on a screen to the world essentially. So I think it like his model will be beneficial. He has a lot of other interesting aspects about it. So if people are curious, they should definitely go read his paper.